Assalamualaikum and very good day to all my students. Today we will learn chapter 1, which is properties of fluid. These are the objectives in this chapter, which is to identify the unit for a basic quantities in the SI system, to define weight and mass, to identify relationship between density, specific weight, and specific gravity, to define pressure, to define compressibility, and to define surface tension. Okay, first of all, we need to know what is fluid. Try to identify where you have encountered either stationary or moving pressurized fluid in your daily life. Consider the water system in your home, such as in kitchen sink tap, in your toilet, and as well as in the piping system. You can also think about how your car fuel travel from the tank to the engine, or how cooling water flow through the engine and its cooling system. And you can also imagine how blood running in your body. Here are several of the major concepts you will study in this course. Fluid is a substance that deforms continuously when acted on by a shearing stress. A solid can be deformed into fluid at certain point for a given stress. Fluid can be either liquids or gases, and they can be characterized by their physical properties such as density, specific weight, specific gravity, tension, surface tension and viscosity. In any technical work, the units in which physical properties are measured must be stated. A system of units specifies the unit of the basic quantities of length, time, force, and mass. The units of other terms are then derived from this. Okay, here are the systems of unit. We have two kinds of system, which is British or empirical units and SI unit. I believe you have learned it before. Why you need to learn units and why units is so important. Units is so important to avoid miscalculation or misunderstanding in your daily life. Let's say your mom asks you to buy 1 kilogram of sugar, but then you bring back 1 ton of it. For example, in scientific field like what happened to NASA, they lost more than hundreds million because of one engineering team used English unit of measurement, while the agency team used SI unit for a key spacecraft operation. A rigid distinction is made between weight and mass in this course. Weight is a force and mass is the quantity of a substance. We relate these two terms by applying Newton's law of gravitation, stated as force equal mass times acceleration, or F equal to ma. When we speak of weight, W, we imply that the acceleration is equal to g, the acceleration due to gravity. Then Newton's law becomes W equal mg. These are the examples on how you can convert 1 Newton of force and 1 pound of force. Pressure is defined as the amount of force exerted on a unit area of a substance. This can be stated by equation rho equal to F per A. Two important principles about pressure were described by Blaise Pascal, a 17th century scientist. He stated that pressure acts uniformly in all directions on a small volume of a fluid. In a fluid confined by solid boundaries, pressure acts perpendicular to the boundary. This principle, sometimes called Pascal law. This is Pascal law has stated. Pressure acting fluid surface uniformly in all directions on a small volume of fluid. And you can see in the image the direction of fluid pressure on boundaries. Imagine that what happens to a liquid or a gas when the pressure on it is increased. How to increase the pressure? By compressing it. For example, air trapped in a cylinder with a tight fitting and a movable piston can be compressed easily. Volume of gas is reduced appreciably as the pressure increases. Like pump to inflate bicycle tire, beach ball, air mattress. If the cylinder contains water, that one is air, this one is water, you could apply a large force which would increase the pressure of the water. The volume of the water could change very little. So for the conclusion, gas are readily compressible, while liquid are only slightly compressible. Compressibility. Compressibility refers to the change in volume V of a substance that is subjected to a change in pressure on it. The usual quantity used to measure this phenomenon is the bulk modulus of elasticity, or simply bulk modulus, E. Because the quantity V and V have the same units, the denominator of this equation is dimensionless. Therefore, the units for E are the same as those for the pressure. As stated before, liquids are very slightly compressible, indicating that it will take very large change in pressure to produce a small change in volume. Thus, the magnitudes of E for liquids as shown in the table are very high. For this reason, liquids will be considered incompressible in this study, unless stated otherwise. The term bulk modulus is not usually applied to gases, and the principle of thermodynamics must be applied to determine the change in volume of a gas with a change in pressure. Because the study of fluid field typically deals with a continuously flowing fluid or with a small amount of fluid at rest, it is most convenient to relate the mass and weight of the fluid to a given volume of the fluid. Thus, the properties of density and specific weight are defined as follows. Density is the amount of mass per unit volume of a substance. Therefore, using the Greek letter rho, P, rho, for density, we'll write as P equal to M per V, where V is the volume of the substance having mass M. The units for density are kilogram per cubic meter, kg per m cubic. In the SI system and slugs per cubic foot in US customary system. Specific weight is the amount of weight per unit volume of a substance. Using the Greek letter gamma, macam Y tu, for specific weight, we write as gamma equal to W per V, where V is the volume of substance having the weight W. The units for specific weight are newtons per cubic meter, N per m3. In the SI system, and pound per cubic foot, lb per feet 3. In the US customary system. It is often convenient to indicate the specific weight or density of a fluid in terms of its relationship to the specific weight or density of a common fluid. When the term specific gravity is used in this course, the reference fluid is pure water at 4 degrees C. At the temperature of water has its greatest density, then specific gravity can be defined in either of two ways, which is specific gravity is the ratio of the density of substance to the density of water at 4 degrees C, and specific gravity is the ratio of the specific weight of a substance to the specific weight of water at 4 degrees C. This definition for specific gravity Sg can be shown mathematically as the equation, where the subscript S refer to the substance whose specific gravity is being determined and the subscript W refers to water. Specific gravity tells us how much the given liquid is more or less denser than water. If specific gravity is, let's say specific gravity of liquid is greater than 1, then it is more denser than water. If specific gravity of liquid is greater than 1, it is more denser than water. Thank you. Any question?